Today we're going to start talking about division, and we're going to look at a specific model that you can use for division. So I'm going to put the date in my table of contents, 7/26, and today we're going to talk about division and then area models is the strategy we're going to use today. And for me, this is going to be page 11. Okay, so when we're thinking about division, we've kind of got to brainstorm and wrap our minds around it. We've done multiplication, which is like the opposite of division. But with division, we've got to kind of think, just like I said, in the opposite direction. Kind of got to wrap our brains around where we're going. We talked about with multiplication, we make groups of something. With division, most times we are putting things into groups. So instead of making more groups, we're taking the big picture or the big amount and putting it into smaller groups. So we are going to look at a problem. We're going to look at 378 divided by 7. Okay, 378 divided by 7. This number right here, 378, is called our dividend. And this number right here is called our divisor. And when we figure out our answer, it is called our quotient. So we have a dividend, a divisor, and a quotient. The way that I remember that this first number is called a dividend, if you think about it in regular format, regular division, if thinking about long division, the dividend always goes inside the house. So long division, you have the little house there. The dividend always goes inside. The divisor always goes outside. And the quotient always goes up top. Okay, so this is what your parents might call the way that they did it, or what we refer to as like the standard algorithm way. We're going to learn the area model way today of how to solve this problem. So really what we're doing is we're taking 378 objects, 378 something of some kind of object. If it was 378 pencils, 378 erasers, 378 apples, whatever it is, and we're putting it into 7 groups. And we're going to see how many total groups we can make. That's the gist of what this problem is asking us to do. Take the big amount, divide it out into groups, and see how many we get. Or put 7 in each group and see how many groups we end up with. Okay, so we're going to come down here, and we're going to get started with area models. The way we do it is we put our 7 on the outside, our divisor on the outside, and in our box, we're going to make a box here. We're going to put 378. Now, it's kind of difficult for me to think about 378 and how many times 7 will go into 378, or what multiplied by 7 is this big number, because I know 7 facts up to 12, but beyond that it might be a little bit more difficult for me. Well, if I think about the power of zeros, with the powerful number of zero, with the 0 on there, I can think about a bigger number. I can get a bigger product, okay? So if I go ahead and put a 0 here, 7 times something, if I know that I'm going to have a 0 right here, because when I multiply 7 by something with a 0 on the end, my answer is going to have a 0 on the end here.
This line is Kenneth. If you're in the building, please call the office.
So 7 times something needs to get me close to these first 2 digits, this 37. I know 7 times 5 gets me 35. So that means 7 times 50 gets me 350 because I just put my 0 on the end. Okay, so then I'm going to subtract. 8 minus 0 is 8. 7 minus 5 is 2. So I have 28 left. So I'm going to make another conjoining box right here. And I'm going to put what's left over. This 28 is going to come right here. So now I've got to think 7 times what equals 28? Well, 7 times 4 equals 28. So I subtract, and I have 0 left over. Now, what I have up here are partial quotients. Just like we used to have partial products in multiplication, these are partial quotients. So they're part of my final answer, or part of my final quotient. Okay, so I have 50 plus 4. So my answer, or my quotient, is 54. So the way this works is you think about 7, here's your original number we were dealing with, 378. 7 times what is going to get me close to 378? Well, I have no clue. But I know that 7 times 5 is 35. That's an easy fact for me to remember. And if I put a 0 over here, that makes it 7 times 50, which gives me 350, which is really close to that 378. Okay? We're going to look at another problem that is actually you should have with you. It's called, let's see here, paper chains. Okay, so we're going to look at the paper chains problem. You should have the paper chains problem with you. I don't have it up under the screen right now, but I'm going to read it. The first grade teachers at Teal Ridge Elementary are creating paper chains to count down the days of school. One teacher volunteered to cut the paper they would need for the chains and cut 1,446 strips of paper. Their paper will be evenly divided between the 8 teachers on the first grade team. How many strips of paper will each teacher receive? So I want you to pause the video here, and I want you to do cubes on your paper where you have the paper chains problem. And once you've done that, you need to cut out the word problem and glue it in right here, or you can fold over the word problem and glue it in right here if you don't have access to scissors. If you don't have access to scissors or glue at home, just put it in, tuck it in this area of your notebook and glue it in the morning when you get to school. So you're going to pause the video, do cubes on your actual paper with the problem. Remember, C, circle the important numbers. U, underline the question. B, box the math action words. E, evaluate what you need to do. And S, solve. And does your answer make sense? Do cubes for that problem, pause the video, and then once you've done cubes on your paper, come back to the video notes and play again. All right, so we have 1,446 strips of paper total, and we have to split this with 8 teachers. So that means I have 1,446 divided by 8. I want to split it into 8 groups. So again, this is my dividend. This is my divisor. And when I figure out my answer, it will be called my quotient. So if I set this up with area models, I put the 8 on the outside, make a box, put 1,446 on the inside. Now, I have no idea how many times 8 will fit inside of 1,446, or something times 8 equals 1,446. I'm not sure. I do know that if I take 8, if I do 8 times, let's see, what would be close to that? If I did 8 times 1 is 8. And if I put 2 more zeros, 8 times 100 is 800. So that gets me pretty close to this number. So I can subtract 800. 6 minus 0 is 6. 4 minus 0 is 4. Now here, I can't take 8 away from 4. If I only have 4, there's no way for me to take 8 away. So I'm going to turn this into 14. And this goes to a 0. And then 14 minus 8 is 6. So I have 646 left over. Now I've got to think, what can get me really close to 646? So I've got to think, that's a big number too. So I know if I can put a 0 right here, I might be able to get something that's closer to these first 2 digits, this 64 right here. So if I think here I have 8 times, what I want you to pause the video and think about what could get you the 64 right here. When we're multiplying, because we have a 0 on the end, so when we're multiplying 8 times something, that could get us close to what we have left over, what could that be? Okay, if you have it, great. If you're still thinking, pause the video and think some more. So 8 times 8
Please come to the front
is
office.
64. So if I put a 4 here, 64 here, I subtract, I have 6 left over. Okay, now this 6 is smaller than my divisor over here. This is my divisor, the 8. Since the 6 is smaller than my divisor, whenever what's left over is smaller, this becomes my remainder. Okay? Because it can't be divided anymore. I can't, 8 will not go into 6. It's too small of a number. It's smaller than my divisor, so I can't divide anymore there. Remember, these are my partial quotients up top. So I'm going to add them together to get my final quotient, and I get 180 as my final quotient. So since the question in our word problem was how many strips of paper will each teacher receive, it's 180. How many strips of paper will be left over is 6. Each teacher can get 180 evenly, but then there's going to be 6 little strips left over, and there won't be enough to give all 8 teachers these 6 strips left over. There will be 2 teachers that wouldn't get any. So each teacher gets 180 strips of paper would be our final answer. Okay? It's our first video notes on division, a division strategy. We'll work on it again tomorrow in class.